Welcome back, everybody. I'm really excited to be having this conversation and every conversation I'm a part of today. But Max Levchin, many of you know who he is, serial entrepreneur, one of the early founders of PayPal, investor, I think, in many companies. He has a small little role being an advisor to FinRegLab. And I will say this, when I was sitting in the Treasury Department, there were a handful of people, most of them are in this room, who, when I left Treasury, I said, that man is smart, or that lady is brilliant, and I want to make sure that they're in our orbit. And Max, you've definitely been that for us, so thank you. We want to get into the topic, though, about AI. You and I had a conversation probably 2 years ago, and then we've increasingly talked about it. What are the possibilities around language models and their value for fintechs, their value for banks, their value ultimately for customers? And I'm sure, I have to imagine you as a technologist have been leaning in on how you can deploy AI in the business, and we'd love to hear what you're doing and what you're thinking on that front.
Sure. Hello, everybody. Nice to be here. It was a little low. This is a little bit louder, right? So we use, I will attempt to not nerd out beyond reasonable, but regulate me towards more or less nerdery as we go.
Go for the nerdery. We like it.
All right. So first of all, it's worth establishing some very basic nomenclature. So large language models are a thing, and we use it quite a lot, and I'll tell you in a second exactly how. But the more foundational insight in LLMs is actually the attention mechanism, or the specific way to use the attention mechanism to generate language. You don't have to use it on human language. And so there are many other interesting things that we can touch on in terms of the usage of this attention-driven modeling. And while I'm in the sort of disambiguation mode, there's this notion of AI, ML, they're the same, they're not the same. For those who care, AI is the general discipline. Artificial intelligence, the way machines learn. Machine learning is the statistical learning where it's highly deterministic, data in, output out, same data in, same output out. I'm sure we'll touch on this in a moment, but hallucinations come from other types of learning algorithms that have, just as a part of how they are built or how they are trained, a certain degree of non-determinism, which makes them really compelling. When you ask ChatGPT the same question, you don't get the same exact language twice, but people in the room who know about such things, wouldn't it be wonderful? You would always get the same result in a credit underwriting moment if that's what you're trying to do. And so all those things sort of mean a lot to those of us in the lending business. So how does Affirm use attention-driven models as well as large language models? By the way, another sort of sub-flavor in the story is small language models, which are really cool and very, very interesting. And the smaller they are, the less room for error, incidentally, and hallucinations and things like that. So to wit, I literally surveyed a couple of my teammates on the way to the stage. This is not exhaustive by any stretch of imagination, but what I said is give me 5 cool examples of the way we're using what is currently being marketed under the Gen AI umbrella that I can actually talk about from this stage.
We have been having this conversation about what can he actually talk about, just to name it, Max.
I'll admit it. So we are a ML AI company and have been since inception. The point of starting the company was this idea that FICO and its many brethren are just too basic. They were born and raised in a time where the debate raged whether logistic regression is the final outcome of mathematical research into the space, or will there be something after? And in the early days of PayPal, which obviously we were at the time, again, pioneering some of these models, the conversation was logistic regression is definitely fine, but if you really want to flirt with decision trees, wow, you're so cutting edge. And we were using random forests, which were at the time were already about 5 and 7 years old, which of course was extreme cutting edge, and no one else in lending or payments used that. And today, random forest is how quaint. That was like a Berkeley circa 1990, whatever. Anyway, so it all moves, and we're in an extreme moment of hotness for these attention-driven models, but there will be something after. That there's no question about that. So, as an example, one of the really cool things that happens where you actually benefit from this non-determinism is all the parts where you're interacting with a consumer where you need to speak their language. One of the things that is very difficult in lending is adverse action notices. You have to make them, like you are required to make them understandable. You can't tell someone, sorry, the answer is no, beat it. It's like, the answer is no, and there's a bunch of things you have to say, here's why. And so we use LLMs to generate explanations of credit declinations or credit decisions. And it doesn't actually matter if it says something like might or may, like those are perfectly fine variations, and the hallucinations are actually welcome, because you can tune the model or fine-tune the model to mimic the way the customer speaks to you. And so you can actually speak their language a little bit more. And it's very, very important in situations where the person is upset and they're sort of having something of a meltdown about, like, wait a second, the answer used to be yes and now it's no. And typical root cause is your DTI is too high, like you are overextended. But the better answer is, hey, I can see here that you have a number of loans with us and others, and you're pushing the envelope of what you can actually reasonably handle on your monthly schedule. So we do this today, it's really cool. Shifting into slightly more edgy things that are not language models. So what makes these attention-driven models, and this is like the area of ongoing research, and we have a large group of people who actually does AI research all day, every day. You can model events that are not human language, and there's now pretty reasonable supply of research papers and just interesting outcomes that show that these models learn time series data, as in sequence of events that have a sort of timestamp to each event, as well as tabular data, which is what's normally used in learning, in sort of typical machine learning. You can leverage both of those two data types concurrently, which is normally a huge challenge in machine learning. It's very hard to encode time, because time is not, it's a variable, but it's a dimension. It's not just like a thing you sort of throw into a tabular data and everything works out. Because like, there's no significance, for example, or maybe there is, but it's not the same kind of significance if you waited a month or a month and a day, but the number is different. So how do you decide how to bucket it? So those are big open problems, or used to be open problems in sort of canonical or classical machine learning. In these newer attention-driven systems, it appears we can really leverage them to learn about time series. So one thing you can do is ask the following question. Here's everything I know about a merchant. They sell a thing, they ship a thing, they sell a thing, they ship a thing, they sell a thing, sometimes they don't ship it on time. What's the next event? Will they be going out of business? Will they be screwing their customers and saying, I shipped it, and skipping town? Right. And a practical answer to that is you can model it, and you can model it to a really good extent, and time series is really important because you're looking at their history, but you're also constantly looking at some rich data sets around what just happened with this consumer, with this loan, how's the loan repayment doing, et cetera. And a very simple application in business is you can graduate the amount of cash you're holding back from that merchant before you're settling with them based on what the model is telling you. Like this person, this business is becoming more risky. It does not mean you want to fire them. You just want to hang on a little before you sort of settle.
Calibrate. Okay.
Exactly. And so that's a good example of a model that we built internally, and it's performed really well. Actually, I'll stop there because I feel like I'm inching closer and closer to revealing secrets I should not. But no, I'm kidding. I feel like I'm getting too long of an answer. That's what I'm feeling.
That's really helpful. We do want to hear how, because we all appreciate the non-determinism of these models, and obviously that raises questions around reliability and confidence. You've referenced small models. You and I have talked about as a process around managing for hallucination. Mm-hmm. Would you tell us how you all are approaching that? Because it is such an elemental question for.
So this is actually, nerdery is required in this. Go for it. So. Yeah. So there's a bunch of really cool papers, and if you're willing to sort of go back a little to high school sort of calculus math, I strongly encourage people search for things like addressing hallucinations research paper. There's a couple out of Thinking Machines, which is obviously an interesting new company, a bunch of academia, et cetera. So first of all, the classical answer, which is wrong, is, well, you just set the temperature to 0. Back in the day, the simple explanation was, well, these chatbots are designed to throw in random words, and so you can set temperature to be some number, and you're gonna get the same response every time, so poof, it's gonna map to things that are regulated or things that you do not want non-determinism. That is not actually true. And you can readily try it, like, go back to one of the older models that had the temperature setting, slam it down to 0, ask a question, sure enough, you'll get a completely different answer. So why does that happen? I'll try to keep it simple, but one of the cooler reasons why it happens, but this is not a complete answer. There's now a very good new paper that just came out sort of beating this reason up and saying, this is not nearly explanatory enough, but it's a cool reason to sort of share in a room of people. So computers represent numbers that are non-integers, basically real numbers, typically as some form of a fixed point math, which means that there's some number of bits dedicated to expressing fractions of powers of 2. You sum them up, and that's your numbers after the decimal point. It should be very obvious that if you have a number that goes beyond the number of bits available, you're gonna have an imperfect representation. Then you do lots and lots of extreme amounts of math with those numbers. An error of an imprecise representation of that number accumulates. Depending on the sequence of how you just simple math, like do you multiply these two numbers together or these two numbers together and then sum the results, same answer mathematically, but you don't have enough bits to store. And so you will have an error accumulation, and the process of error accumulation is not deterministic because all these GPUs have a fixed point math powering them. So you end up with numbers that are kind of the same, but they're kind of not. They actually have digits that are not visible, not stored. They're not there, you don't know what they are, and that is literally what indexes into the next token, and that's how you get the word that is not the word you're expecting. And so, anyway, so this is it's one of these
We need a whiteboard, Max. Keep going.
I delight in these little, I think, amazing things. If you want there's a very famous, very sad, unfortunately, accident in the history of NASA where they tried to land a probe on the moon and completely missed the mark. Bizarrely, same exact reason. Not enough bits to store precision. So it's the classical precision of integer stored floating point numbers bites humans every decade or two. This is a big part of non-determinism. There's more to it than that. Probably the more interesting part, or less interesting part perhaps, is GPUs execute things in parallel, depending on which computation completes when. Yeah. Sort of feel. Yeah. Anyway, the good news is, so now people, this is like the paper I'm referring to in my head here came out in September of this year.
Okay.
So this is very new. And there's more and more papers coming out saying you don't have to settle for this idea that LLMs are non-deterministic. Like, we can understand what makes them, they're not magical, it's math. You can start addressing it. It may be costly, you may have to take some shortcuts, you may have to do some things that are a little bit different, but you do not have to just say, oh, you know what, sorry, pause up, we're not gonna settle. And so what we do internally is we actually do the hard work of asking, and by the way, we knew some of these things. Like the papers are now public, so I can sort of rattle it off as if it's common knowledge. But long ago, we'd ask the question, do you have to settle for non-determinism? And the answer is no. You can actually do much more than that. You eventually run into length of registers, length of memory storage, but
computational power.
Computational power insofar as, are you willing to wait? Like, of course you can compute it all you like, but if it takes a decade, it's not useful.
Yeah. You got a credit decision to make.
Yes, I have a credit decision to make, and the SLA is 5 seconds. So, but inference is actually cheaper than training. But the interesting thing is that I think we're entering a stage where a lot of these, you can't touch this stuff, it's just totally not deterministic, can't predict it, is still a major, major topic of conversation, but you don't get to be like, well, and therefore 12 rings of fire surrounded by legal compliance, behind many.
Well, so to that end, just to bring it back to evaluation and deployment in a highly regulated space, have you had to change your processes around using these models so that you feel like you're able to satisfy your own, your own expectations around, firm stability, model stability?
Actually, the thing that I didn't get to, but this works well. So I think you already heard it. I missed some of the conversations, but this is a thing that people are using very, very widely, but maybe slightly different take on it. So we use Gen AI and LLMs, including tools that we buy as opposed to build internally, for feature development. And what's really powerful about that, and again, this may have been said already.
It hasn't. Keep going.
It's better than humans, like way better than humans. So a typical, so imagine I do not normally look like this. I was waiting for someone to mock me for it, but
I
you
did not.
spared me, thank you.
Yeah. I thought you dressed up for us in the Kennedy Center, but yes. Yeah.
Of course, yes, I did. This is an 8th attempt to tie a double Windsor knot today. I think it looked fine, but I had to consult my wife, like, does this look okay? Via video. So anyway, the point is, where was I going? It's much better. I do not look like this normally. Normally, I look like somebody who likes to wear a hoodie and type a lot. So imagine that person, sort of person that normally looks like me, deciding to build the next generation of a credit underwriting model. Yeah. What they do is they say, all right, so what could go, actually a merchant underwriting model, a better one. So let's keep away from various for lending concerns here. So we're deciding whether merchant is actually worth adding to our network. And so one might say, like, we need some reputational signals. We need to figure out if this merchant is actually legit, if they've been around long enough, so we can look them up, we can get their DMV record data, we can get some Better Business Bureau data, and at some point, like, well, we need some consumer input, so we're gonna have to go process some Yelp reviews. So we're gonna go to Yelp.com, download the list of reviews, and be like, all right, cool. What can you, and you're on a deadline. We release a new model variant at least once a quarter, and a major model variant every quarter, typically a few times a year. We try to fine tune the models a little bit better. So you're not gonna be like, I'm gonna read all about these businesses. Like, how quickly can I figure out if there is information value inside Yelp reviews? I'm just gonna write a quick counter, like, how many times does the word great appear in these reviews? This is not made up. Like, this is how you do business underwriting feature construction. Just write tiny little quick scripts, pull off a bunch of text, like great, good, some synonyms. All right, cool. Like that's a good business. And then like crappy, bad service, hate, that's a bad business. Okay, good. That's going to be a variable. There is a lot of content in these reviews that is not good, bad, great. In fact, like a delightful dinner with my future wife convinced me this is the right person. Like, there's a bunch of information in there. One of them is like, obviously you're in love. That's okay.
Yeah.
That should discount how much you like this restaurant. Like, you weren't paying attention to the food at all. And so it turns out that LLMs are extraordinary at capturing sentiment inside these reviews without ever translating it into good is good and
no
sucks is bad.
rules-based approach.
It is not a rules-based approach.
Yeah.
It is an embedding in a vector space of human language, which of course, thanks to all these major frontier model builders, they've completely encoded. And so what you have is like, I take a Yelp review, shove it through something that will turn it into an embedding, and there you go. You have a business that, like, you don't have to understand why this is a 135-dimensional number set. It just tells you how it ranks against all the other businesses and how that correlates to quality of customer service and shipping on time, et cetera. And so we do that like nobody's business, and the frequency with which we can release new models on the consumer or primarily on the business side has skyrocketed because you don't have to manually puzzle over, well, do I use great or is that an overused word?
Totally. That makes a lot of sense. And are these agents that are out there able to pull that kind of data? I want to move into the conversation about agentic AI and...
So, yes and no. We're very early in the agent world. So I'm naturally a very skeptical person, being a credit underwriter. It's like occupational hazard. If you're too positive, you're going to go out of business. And so I try to be quite skeptical about old new technology as much as I delight in understanding how it works. Agentic loops are rapidly going, getting better and better, but just practically from my point of view, there's still a lot of humans in the loop. Like the AI is not yet coming for all our jobs simply because it is very, very good at a singular focused task. The next focused task is go automate this full process, but context length alone limits just how much of the process can you keep in memory of your agent. And so we're not quite to a place where, like, no company out there, Affirm included, has yet figured out how to say, here, take all this data, build me a credit underwriting model, let me know when you're done. Yeah. That's not a thing. But even like, build me a model that does this really, really basic classification, also not a thing. Humans involved in every step, which is actually how it should be for maybe forever, but certainly for quite some time.
Right, so technical challenges around agentic AI, but also can we trust it, level of human oversight, even when you're deploying it, to get a sense of where would sort of a multi-agent system work well, where does it work poorly, more to learn, it sounds like.
Certainly yes. And again, we love to live at the cutting edge, so we'll try anything, both tools we build and tools we can license. But we're very careful to deploy them. Certainly we'll never deploy them without human oversight for quite some time. So there's tons and tons of just monitoring what actually happens here.
Yeah. So you sit in the world of merchants, e-commerce, commerce, consumers. We're not there yet, but what do you envision in terms of the possibilities of, or what would you like to see in the context of the future with agentic AI in the commerce consumer space? And you are coming from California, where I understand there's a lot of enthusiasm around agents. You can push back on any of that. But,
Can I start with California? No. So to sort of maybe pull in one thread. So agentic commerce is all the rage. So we have all these sort of stories about how any minute now you're going to just like buy me a dress, make me look good. That's about, in my opinion, and I do not buy dresses, but I know someone who does really well, and she tells me that a huge part of the process of buying a dress is entertainment. And I just don't see how most people who find the process of looking at a thing and imagining themselves wearing it or enjoying it, whatever that means, outsource the thing entirely. And so there are subcategories of agentic shopping, agentic commerce, and I think agentic work. Like, I think the reason I picked on agentic commerce is because actually it's a good projection of other things. So agentic commerce is alive and well today. I tell Instacart, buy me the same thing you bought me last week. What's annoying about that is within 15 minutes, bananas are green. What do you want instead? Like, in the middle of a stage conversation at FinRegLab, and I'm not in, don't have the liberty to explain to you that green bananas will become yellow. Just, go ahead. And an agent will do just fine if you tell them, and there'll be two agents. One agent will speak on behalf of my ability to discern banana aging processes, and the other one will say, oh, I will then roll my robotic body to the least green banana and pick that up. Yeah. And maybe like, hey, can you check in the guy's banana stand at home how yellow are the ones he has right now, because then I can decide. So that stuff, that's coming very soon, and it will just make the lives of Instacart shoppers a lot easier. Could also take away some of their jobs. On the very far side of that same conversation is the part where my wife says, like, I am never giving up my God-given right to flip through a glossy magazine and saying, that looks beautiful, and I kind of imagine myself in it. What do you think? That's a part of life that we enjoy. I'm not sure robots need to come for that, and if they do, we'll fight them. The part in the middle that is really, really, really hard is this idea of we have these processes in life where parts are delightful and parts are extremely annoying. Yeah. To sort of hop away from agentic commerce for a second, when I'm not wearing a tie, not necessarily wearing anything like this, I write a lot of code. Writing code for production purposes looks kind of like this. 25% of the time, I'm an artiste typing away beautiful algorithms, and I actually quite enjoy an agent on my virtual shoulder telling me, here's a really good way of solving this problem. Sometimes I'm like, yeah, that's stupid, I don't like it. Sometimes that's brilliant, thank you for, and again, all of this, of course, is happening in my head. I'm mostly just typing code or watching code being written for me. That's 25% of the time. 75% of the time, I have a thing, I'm gonna stage it, which is I'm gonna test it on some fake data to see if it works. If it doesn't work, I'm gonna take it back and start fixing bugs. Once that's done, I'm gonna deploy it into a canary, which is a place where real people, real users will see it, and if it starts crashing, I'll get a notification. Now, all those steps right now are primarily manual because it's really flat and boring, and engineers that are building these amazing models that help me code just haven't gotten to that part yet. To do it well, you're looking at a very complex process that has lots and lots of pullbacks. We're like, this is great, we're gonna roll it out, we're gonna put out in a canary, oh crap, it is crashing and we're seeing problems. And we're gonna pull it back. Now it's crashing, but it's crashing on a live site. Do we need to do more? Do we need to recover? Do we need to unroll some data? Actually, it's not crashing. It's crashing because some other thing got pushed and they are now conflicting. And so the complexity you're dealing with here is very, very, very significant. And it's also not the most artistic part of software engineering at all. Just like it's not, the parts that are being solved right now are the most artistic parts, most interesting parts of commerce, software engineering, all the things that we are poking at with agents. we're not super close, in my opinion, to having agentic systems that a single agent can handle the entire process, just because the context window that you have to have, this is both a human context window expression and the actual mathematical definition of context window in these attention-based models, they're not nearly big enough. Like, imagine just the thing that I described very roughly. There are many, many, many little things that make it complicated. You're looking at potentially much longer context windows than we have access to today. So again, compute, energy, et cetera.
Right.
So I am a techno-optimist, to make no mistake, but my guess is we're going to be mopping up the long tail of complexity of all these things for quite some time. Like, we're not yet, now, just to sort of fully disclosive, if we get to AGI somehow.
Oh, we did say we're not going to talk about that, though. All done.
Yeah, I'm done. If we do get there soon, you can imagine the solution to all these problems that I try to surface, the window of solving them just really narrows, because presumably AI can outwork us all. But
are you optimistic on that?
An AGI?
Yeah.
I'm optimistic in the sense that I do think we get to a place very soon, actually, where you have a smarter angel on your shoulder telling you things. So the thing that I'm most excited about, my little world, big world actually now, lending, borrowing, et cetera, there's an enormous arbitrage in human stupidity available.
That's where I was going to go next, and we're going to close out on this. So tell us what you think.
So I'm wearing a tie because I met a bunch of Congress people today, and I basically retold my life story some uncountable number of times now, but the relevant part is I was a teenage immigrant from Soviet Union. I got my first credit card on campus. I did not read the fine print. There was an asterisk next to 0% loan, and I got rolled over by deferred interest, which wrecked my FICO score, and that's actually kind of what motivated me to start Affirm. True story. You can get more of it's been well documented online. But the reason for it, I wasn't even dumb. I just didn't understand what to look for. I didn't know the business model was hidden in the fine print. We are about to enter the age where it doesn't matter if you have a 105 IQ. You have a thing constantly watching over you saying, that asterisk that you can't even detect tells you, do not touch that financial product.
It's going to kick your butt.
It's going to make your financial decisions much harder going forward. Do not do this. Let me give you 5 recommendations that's going to be just fine, much better for you. And so the arbitrage of people making money on your lack of attentiveness, lack of education, lack of intelligence, lack of people to lean on and find out is going away very, very, very quickly. Like, I know there's a lot of bureau people in the room, and so I'm probably pouring one out on the curb for the brief rise and fall of the late fee cap, which I thought the right cap should have been 0, but that's my personal opinion. So the disappearance of late fees is coming, and actually, from my capitalist point of view, the better way, not the regulatory no late fees or low late fees because it's bad, no late fees because no one's going to be stupid enough, pardon the...
Or clueless enough.
Clueless enough, that's
yeah.
Much better.
Right.
I say stupid in a sense like, how could I have been so stupid? Like that's the stupid I'm referring to. And so the cluelessness of the consumer who says, oh, I'm never going to be late. Also, I'm never going to be unable to pay this loan because I'm going to win the lottery. Yeah. Like, sure. Probability suggests you won't. And so that is all going away, which means that very, very soon, those whose business models depend on late fees, deferred interest, consumers believing they're somehow going to find themselves in possession of a pot of gold is going to go away.
Right.
And I cannot wait for the future. That's going to be awesome. So I hate the...
It's positive for all of us. But probably negative for lotteries.
Lotteries are a form of entertainment. I do not play them because I can understand the probabilities and find them unacceptable. But at least when you're buying a lottery ticket, you're like, it's super low odds, but maybe it's my lucky day.
Fair enough.
I think that's actually the least evil. I am confident that 0 with a giant asterisk is definitely not going to charge me a penny of interest. That's cluelessness, and we need AI agents right now to make us less clueless.
That's awesome. So thank you, Max. Really, really appreciate the deep dives. We will bring a whiteboard next year, for the...
Next year, ask me, how is that fixed point math going for you? Because I might be able to tell you, here's a model that we built that has true determinism and yet based on attention.
Great. That's good. We might ask you before next year, by the way, because there's a lot of interest and need to understand how do we use these things with enough confidence in this really essential, highly regulated space. But thank you, and I love the enthusiasm for financial agents. We're going to be digging into that deeper in the conversations ahead. So if you will join me in thanking Max.